So in the given equation, k is a constant. The equation has no solution. What's the value of k? So in this case, I'm using method 2. I have actually produced the video on method 1 where I stated some conditions. So for this method 2, we are going to be making use of the slope-intercept form because that is where it is very important. So a system of linear equations have no solution if the two equations have the same slope but different y-intercept. So how do we now get that done? If you look at this left hand side of this equation and this right hand side of this equation, we can express both of them in slope-intercept form. But before we do that, let's first open the parenthesis, that's the bracket, and then we'll see how we can go about it. But we can model both equation in slope-intercept form. Then we now apply the condition of a system of linear equation with no solution. So here we have 3 into bracket kx plus 13 is equal to what? That is 48. This is 48, not 46. So over 17, 48 over 17x, right, plus what? 36. So let's open this bracket. We have what? So give us what? 3kx, right, plus 3 times 13, and that will give us what? 39. Right, it's got to what? 48 over 17x plus 36. So what this means is that each of these equations, they have a subject, so we can actually model each of them in slope-intercept form. So therefore, from the left hand side, which is this one, we can write it as y is equal to what? 3kx plus 39, right? Y is equal to 3kx plus 39. So we can call this one equation 1. Also, from the right hand side, we can model it in slope-intercept form. That is y is equal to what? 48 over 17x, right, plus 36. And this one represents what? Equation 2. Now that we have written both of them, right, in slope-intercept form, let's recall the condition again. The condition says that a system of linear equation will have no solution when the two equations, right, have the same slope but different y-intercept. So definitely equation 1 here, the intercept is 39. Equation 2, the y-intercept is what? 36. So it has fulfilled the condition. But how are we going to know if they have the same slope? It implies that there is a value of k here that will make this term to be equal to this term. That will make this slope and the slope to be the same, because that is the only condition. They must have the same slope and different y-intercept. So let's find the value of k that will make them to have the same slope. And to get that, we equate this and this to get the value of k. So we can say that 3kx will give us what? 48 divided by 17x. So this cancels this. So what do we do next? We cross multiply. If you check the first video, I actually did something like this there. So if we cross multiply, we're gonna be okay. Before I cross multiply, we have 3k is equal to 48 over 17. So 3k times 17 is equal to 48. So 3k times 17, that is 51k, is equal to what? 48. Divide both sides by coefficient of k, that is 51. That is 51. This cancels this. So we have k to be equal to what? 48. 48 divided by 51. And if we simplify this further, that will give us 16 over 17. And that will give us what? I think I expressed it in decimal in the previous example. Yes, 0.9411. So what does this suggest? It implies that 16 over 7 is the value of k that will make the system to have the same slope, even though we have confirmed that they have different y-intercept. So it is the value of k that will make that to be possible is what? 16 over what? Over 17. How to believe this video has helped someone. Thank you. See you in the next video.